Hello everybody, welcome to T1 Day 6 of Honors Precalculus. Today we're going to start reviewing / looking at for the first time, depending on where you're coming at it from, exponential functions. So first of all, what is an exponential function? An exponential function is a function that changes by a certain percentage each time period. This is a little general and we're going to see certain forms of it, but the key is it changes by a certain percentage each time period. There are three forms that we're going to look at of an exponential function. Here's the first. Y equals a times b to the x. B is called the growth factor, and it's also notarized 1 plus r, where r is the growth rate, how much the quantity is growing by. B greater than 1 means it's growing overall, and b less than 1, it's decaying, and a is the initial amount, The second way we're going to go about notarizing it is like this. Continuous growth is the second way. A equals p times e to the kt. E is the number e, which you may have seen before. It's like pi. You can estimate the decimal, but if you want to write it in its exact form, you write it as e. But it's 2.718. You can memorize the decimals. They go further. K is the continuous growth rate. This is key. As a decimal, that's important. So if k is greater than 0, it's growing, and if k is less than 0, it is decaying. These just takes practice to get familiar with. The third form is a equals p times 1 plus r over n to the nt, and you see this a lot when you work with money. Here's what each of those terms mean. P is the principal, which is just a fancy way of saying starting amount. R is the nominal rate, meaning like what the interest rate would be over an entire year or an entire t here. And n is the number of compoundings per time period, and t is just the time period. Usually in years is really common when we're dealing with money. So for example, if we're just as a side note dealing with months, n would be 12 because there's 12 months in 1 year. If we're doing days, we'll use 365. So yes, this seems like a lot of letters to remember, but it's really important that you practice them and you will get these into your brain. So it's 1, 2, and 3. You need to memorize these. So with these questions, it's stating, state whether each of the following represents exponential growth or decay. So that's key, growth or decay. Then state the continuous growth rate and the effective growth rate. Let's see what those are by calculating them. So this one fits the first form, and that's right there. That's the number. That's the b value. Remember, b plus is 1 over r. So in this case, it's 1 plus 0.6. But it also tells us that when b is greater than 1, it's going to be growth. So we know that this is growing. And the effective rate is going to be the r value. That's the effective growth rate. So in that case, the effective growth rate is 60%. 60% is the same as 0.6 in decimal. And the way you figure out the continuous growth rate, and that would be, how would you get 60% in 1 year if you were doing a continuous growth rate all year? You have to solve this. You take b equals e to the k, and in this case, b is 1.6. So you're solving this right here to find out the k value. That would be the continuous interest rate. So to do that, you take the natural log of both sides. Ln of 1.6 is equal to ln of e to the k. K can be brought to the front because of log rules. So you have ln of 1.6 is equal to k times ln e. Ln e is just 1. That is 1. So k is equal to ln 1.6. And if you do that on your calculator, you end up with a k value of 0.47. So that's 47%. So that's the continuous interest rate. The continuous interest rate is always going to be lower than the effective interest rate. So let's go in the opposite direction here. This is in continuous interest rate form. And right here is the k value. So we know that k in this case is equal to negative 0.05, which is less than 0, so it has to be decay. If k is less than 0, it is decay. So the continuous interest rate is right there. It's going to be negative 5% because negative 0.05 is equal to negative 5%. It's decaying. But then you have to figure out 1 plus r, that would be the b value, is equal to e to the negative 0.05. This is where you definitely get to use a calculator, and if you do this out, you plug that into your calculator, subtract 1, you end up with r is equal to negative 4.877. So in this case, this is the effective rate of decay. That would be the simple interest rate. And again, negative 4.8 is greater than negative 5. maintaining the same relationship as before. There are 2 more examples here. I will let you do them on your own. Good practice right there. It's in your sheet. You can also take a screenshot right there and work on it on your own. It's the same work. This one you're going from, just as a hint, 1 plus r in this case is 0.75. And in this case, you have your continuous function and you have e to that. So in this example, we're given 2 points and we're being asked to find an equation. Really, we're finding an equation and we're given 2 points. You just have to take the equation, what they give you, and find out what those 2 points are. So for example, on the 12th of March, there were 108 reported cases. And then 31 days later, on April 12th, 31 days later, there were 25,475 cases. So you can write these points based on their date or the number of days later, but it's really the days later that you need because time moves on, it doesn't reset. So the first point you have in blue here, the blue point is going to be 12, 108. But then 31 days later, the green point, our second point, is going to be 31 plus 12 is 43, 25,475. So we have 2 points, and it's asking us to find an equation, and it's telling us that it's growing exponentially. Now, the equation we're going to use is the y is equal to ab to the x. It's ab to the x is what we've had before. We can use t because it's time. But we need to find out we need to find out a and b in order to figure out what the equation is. There are 2 unknowns here. There's a and b, and we have 2 points. How do we do this? Well, we set up 2 equations and solve, like so. So all I've done here is I've plugged in the 2 points and created 2 equations. We know that the output is 108 when you plug in 12, which is what I did there, and the output is 25,475 when you plug in 43. So we have 2 equations. What do? We're just going to divide both sides of the equation by each other. So what do you end up with? 25,475 over 108 is equal to AB to the 43rd over AB to the 12th. The nice thing here is that the a's cancel, and because of rules of exponents, you end up with this decimal here, and you definitely use a calculator. 25,475 over 108 equals b to the, you subtract the powers, which is b to the what power? B to the 31st. So how do you go about solving this? Well, to get rid of a square root, to get rid of a square, you use square root. To get rid of a cube, you use cube root. But now you have 31st power. So what you're doing is raising this to the 1 over 31th power. So you're taking both sides and you're raising it to 1 over 31, because when you have powers of powers, they multiply. 1 over 31 times 31 is 1. So b in this case is equal to 25,475 over 108 to the 1 over 31 power. That is something you can just plug into your calculator and you end up with 1.1927. It's really important that you round at end if you can. Round at end. Try not to round until you get to the end. But that's just the b value. We now have 1.1927 for our b value. We need to find the a value, and we do that by picking any of the other points. So what I mean by that is we have y equals a times 1.1927 to the x, and one of our points is 12,108. So one thing we can do right now is just plug in 12,108 and solve for what we need. So what that means is 108 is equal to a times 1.1927 to the 12th power. You can do this on your calculator and divide both sides. See if a is equal to 108 over 1.1927 to the 12th. You use a calculator for this and you get 13.03. I don't have the third decimal right here, but I'd like that. So your final answer would be y equals the a value, 13.03, times the b value, 1.1927 to the t. You could say x is fine too, but I'll say x for now, that's fine. So this would be our equation. We now have an equation that models what we want. It's a lot of work, but you get to use a calculator. So what does it mean to plug in 15? It says evaluate c of 15. So if we write this in the form we wanted, which was c and t, we would have c is equal to, once again, 13.03 times 1.1, what was it? It's all the way over here, 1927 to the t. What does it mean when you plug in 15? Well, 15 is a t-value, so it means that on March, what was it, what number? On March 15th, when you plug it in, C of 15, you just plug in 15, you end up with about 183. On March 15th, 183 people had COVID-19 in Massachusetts. In Massachusetts. Similar, but the other direction, what does C inverse mean? That's the output, meaning 11,736 is equal to 13.03 times 1.1927 to the t. You're solving for a t-value. So you have to use your calculator in logs, and if you solve this using a calculator, you end up with t is equal to 39, which means that 39 days after our start, so after March 12th, it means that 11,736 people have coronavirus in Massachusetts. It's the opposite direction. Now this right here is using your calculator. You need to use logarithms to solve this. This is something we can work on in class, but logarithms. You need logs to solve that. Lastly, it says, what is C40 minus C10 over 40 minus 10? Well, this right here is how many people have coronavirus on the 40th day, how many people after March 12th, and that's after 10 days after March 12th. That should look familiar. This is just the slope between 2 points. It's the slope between the 10th day and the 40th day. It's the slope between the 10th day and the 40th day. So if you evaluate this, you can use your calculator, and you'll end up with a value of C40 and a value for C10. You end up with these values. You need your calculator, you plug it into the original equation, and when you calculate this slope, you end up with 4.975. And in the context of this problem, the slope, so the graph is going up, and then you're calculating the slope between these 2 points right here. There's the 10th day after March 12th and the 40th day after March 12th. The slope of this line was calculated to be 4.975, which is going to be the number of people per day infected between March 12th and 40 days from March 12th. And I just caught one typo on my calculator. When I did this out, it actually is 497, which is way better. Makes more sense. So it means 497 is the number of people on average infected per day between March 12th and 40 days from March 12th. So in this next problem, you're doing something very, very similar, but it's growing at a continuous rate. So instead, you're going to start with A equals PE to the KT and do the same type of work we just did, but with the continuous interest. And if you need practice at the end here, there are some great questions where all you're doing is trying to solve for x. Just try to solve for x. As an example, you need to isolate everything that has x in the exponent first. So in this case, you have 25, 1.2 to the 2x plus 1. Subtract 2, you get 25. Turns into 25. And then you divide by it. Divide both sides by 25. 1.2 to the 2x plus 1 is equal to 1. And now you need to use logarithms to solve this. Logarithms. That will be log base 1.2 of 1 is equal to 2x plus 1. You convert, because it's this to this power equals that. So when you do this, what do you end up with? Well, log of 1 of base anything is just going to be 0. So 0 is equal to 2x plus 1. So when you solve for x here, x is equal to negative a half. You can plug it in to check. So that's one example. There's lots of other questions you can practice this with.